going to go through this question in two different ways, both of which you can use the ideas of similar triangles. First way is the quickest, but requires knowledge of like how you go from similar triangle lengths to similar triangle areas. Second method's going to avoid that, but it's going to be a bit more involved. So, method one, let's say that the area of this triangle AEI is x. Now, AFJ is then a similar triangle to this because I've got the same angles. I've just enlarged it slightly because remember, we're told that the rectangles are congruent. So this length is the same as this length. So for AEF, I've doubled the lengths. And what that means is because I've doubled the height and, doubled the base and I doubled the height, then the area, in fact, is going to become 4x. You can get there by saying the length scale factor is 2, so the area scale factor is 4. You end up squaring it, which means that this is 3x. And we can do exactly the same with the larger triangle, this time ADK, but AD is 3 times AE, which means that the area scale factor is 9, and the area is going to be 9x. So that means this is going to be 5x. We're then told that JK divides CDFG into two parts of equal area. So that means that this is also 5x. Actually, let me do this in a different color now. Okay, so each rectangle has an area of 10x. And there's 3 rectangles, so they are overall going to have an area of 30x. You could even work out what these are. This is going to be 7x, and this is going to be 9x, which means the area of triangle AEI as a fraction of the area of the large rectangle ABCD is going to be x. The triangle divided by the whole thing, 30x, which gives 1 over 30. Here's an alternative way to do this question. So I decided to say that this length here was A, and then each of these lengths are 1. Now, that bit is not actually essential. I could say that they were Y or X or something. I just decided to not introduce too many symbols. As we enlarge the shape, then it's not going to affect the fraction. That's quite important. And so I can make it the size such that it's 3 in length in total. And what we then get, the area of the big triangle, is going to be 3.5 times 3 times A, so 3 over 2A. And now the aim again is to get this area. But first, actually, I can then get the area of the small triangle. A, E, I. Because they are similar, they have the same angles, and this one's just 3 times as small, which means the height here will be A divided by 3. And this is 1, remember? So I'm going to get as the area 1/2 times 1 times A over 3, or A over 6. Okay, that's going to be useful. Then if I look at this triangle in the middle, AFJ, then this is 2, which means it's twice as big as the smaller triangle, so it's going to become 2/3 A, or 2A over 3. And therefore the area will be 1/2 times 2 times 2A over 3. These cancel, so that's it, 2A over 3. Which means the red area, this is the important bit now, it's going to be the area of the big triangle ADK, so 3 over 2A, minus the area of the triangle we just found, 2/3 A. Put it over a common denominator, 9 over 6A minus 4 over 9A gives 5 over 9. Sorry, that should have been over 6. 5/6 A. Which means the whole thing here is then going to be twice that, so 5/3 A. And the area of A, B, C, D will therefore equal 3 lots of that, because I've got 3 rectangles, 3 times 5/3 A, which is 5A. And we're nearly there, because now the fraction is going to be 1. Actually, sorry, I think let's go down. Fraction of that the triangle makes up of the whole rectangle is going to be A divided by 6 divided by 5A. This is the same as A divided by 6 times 1 over 5A, because this is 5A over 1, which gives A over 30A, which again gives 1 over 30. Now, there's no denying it. It's a bit more technical. We've had to do, fractions, for example, but it's not, okay, yeah, this is, you can see it's just a bit neater, but it required knowledge of area scale factors, and, now you know about them, but if you didn't, then the method below would have also have really helped.